So we're back and we are ready to install the small 3-element stacked rosette. This is the 031 WWA. That's a 350 ohm resistance. And Ben's going to take us through the installation of this gauge onto a small composite beam. This is a small fiberglass beam. It's actually a G10 material that is just a fiber reinforced resin-based beam. Real typical for composites. One of the nice things about this material, G10, is it's widely available. You can buy it from a variety of sources. We like to use it as practice material for installing gauges on composites. And one of the nice things about it too is that it's very repeatable. So if you buy some today and you buy some 6 months from now, we usually find that the properties repeat pretty nicely. And that's important for us in applications engineering because a lot of times we're using materials like this in some of our training programs and we need that repeatability. So with that being said, Ben's going to take over. And as with any strain gauge installation, typically the first thing that you do is you want to degrease the surface. And Ben's going to do that using the M-Line GC6 isopropyl alcohol. Very simple, very easy. Take a gauze pad, pour some of the GC6 into it, and just wipe off both sides of the beam. I like to wipe the whole thing down just to make sure we don't have any contamination on the top side, maybe where we're putting the gauge, but also on the bottom side and the edges. So I just wipe the whole thing down. And then once we do that, we're ready to abrade the surface. And composites, just like metals, typically you want to create some texture for the adhesive to be able to bite to it. I say, Ben, let's just put the gauge about in the middle of this beam. Here in this exercise, we really want to illustrate how to do this. And placement of the gauge is really not that critical. But what he's going to do next is take a piece of 400 grit silicon carbide paper and abrade back and forth about 10 or 12 strokes in the middle of this beam. And what you're really trying to do is take off the shine, which means that you've added some texture for the adhesive really to bite. And one of the unique things about this strain gauge, and Ben's going to need to watch this, is that this gauge, not only we're going to glue the gauge down, but we're also going to bond this flexible circuit as well. So we want to make sure that we have enough area prepared so that we can glue the gauge and that entire flex circuit down onto the surface. So just be mindful of that as you're prepping the surface. You know, you can take and compare it. If you need to go a little further, feel free to do that. And then once we got that surface roughened, we're going to take a gauze pad and just kind of wipe across it. And there you can see, if you hold it up in the light, Ben, maybe we can see that a little bit better. You can see that it's got a little texture on it now. Now it's getting kind of dull, and that's what we want. You don't want to be too aggressive with these composites because a lot of times they have fibers at the surface, and the fibers help to add a tremendous amount of rigidity. So if you start aggressively abrading, you could start cutting through some of those fibers and you start impacting how that composite's going to carry load. So we're just trying to scuff it to create that nice dull finish. A conditioner, the red tip bottle. Again, this is a mild phosphoric acid. It's going to help to chemically etch. So we take a few drops, put that on, and then take some of the cotton tip applicators and we scrub the surface. This beam's already in pretty good shape in terms of cleanliness, but we're going to scrub it with conditioner, and then we'll follow that with a scrub with neutralizer. You could debate about whether or not conditioner and neutralizer are critical steps for a fiberglass beam, but in my book, it's another cleaning step, and it's not going to hurt anything to expose that fiberglass beam to conditioner and neutralizer. Now, so once you've introduced the conditioner, the mild phosphoric acid, that's, again, a cleaning step. Now we need to neutralize it for the adhesive. So what this will do, this is the neutralizer. It'll bring the pH back up to an acceptable level for the MBond 200 that we're going to use to bond the strain gauge. So again, a few drops of neutralizer on it, scrub back and forth. Again, prepping a nice big area for the gauge and the flex circuit. All right, so basically at this point, make sure you're working on a clean, dry sheet of paper. So if there's any moisture on the piece of paper, just take that, throw it away. You've got a cleaned surface. Okay, so we have a clean surface. We've got the gauge. Take the beam, scooch it to the side, and let's get our piece of glass. And we need to do a little bit of house cleaning. So what I like to use is the blue tip bottle. Take the conditioner and push it to the side. Blue tip bottle, that's the neutralizer. This is what we like to use to clean the surface of the glass in this case, as well as our tools. And we'll use a gauze pad to clean it. You could use a cotton tip applicator, but it'll take you a little longer. But just a gauze pad and just wipe off the surface. Again, you're looking to make sure if you've got any dust on it, you're wiping that off. If there's any smudge marks, fingerprints, things like that, you're trying to get those off. And what I like to do at this point as well is find my blunt nose tweezers, and I'll usually, because I might use those to handle the gauge, and I'll typically clean those off as well. So a couple of drops of neutralizer in a gauze pad. Yep, just pull it through. Okay, we're ready. So now we can go ahead and remove the gauge from that little sleeve or folder. And basically now we can just lay it onto the piece of glass. We want to make sure we lay it with the shiny side up and the dull side down. If you look at it closely, maybe hold that up in the camera so we can see it, but you can see the solder connections. So you want to lay gauges with the solder connections facing up, of course. And now, once you get it kind of positioned on the glass, one of the little tricks that I like to use sometimes is I will just put a little piece of tape down here on the glass to hold the wires down, and then put the piece of tape over top of the wires to hold it down. And then run the piece of tape over top of the whole strain gauge, in this case flex circuit as well. Just a temporary piece. It kind of helps keep the thing from, standing up in the air and stuff as much. So once you got that down, now we'll take a piece of tape and just cover over top of the whole gauge and the flex circuit. And we'll use this piece of tape to pick it up and transfer it from the piece of glass over to the cleaned G10 composite beam. Ben likes to put a little fold right at the end of it. It helps to give him a little handle to deal with the tape. And he'll just tack it at one end and wipe it down. All right, that's simple and that easy. So now we're ready. We can pick it up. Technically, we can pick it up from either end at this point and transfer it from here over to the cleaned composite. You just want to be careful that you don't pick it up at too steep of an angle, because you could damage the strain gauge. And what I mean by that is try to keep that angle less than about 45 degrees. Once you get on past the gauge, you can go ahead and pick it on up. Let me get your glass out of the way for you. And then right in about the center of the beam, we'll take it and tape it down into place. All right. Now at this point, you're basically ready for the adhesive system. So we're going to use the MBond 200. This is our most common adhesive system that's used for experimental testing. MBond 200 is a cyanoacrylate. typically associated with room temperature or relatively moderate temperature testing. In general, you don't want to use this if you're getting up above about 150 degrees Fahrenheit or going below about minus 100 degrees Fahrenheit. So around room temperature or mildly elevated or mildly on the low side, but any sort of cryogenic testing, this is really not the right adhesive system. Or if you're expecting temperatures above about 150 degrees Fahrenheit, or if you're wanting it to last long term. If you expect the adhesive system to last for years, this is really not the right one, but we've got a bunch of other epoxies you could use for that. But for this application, just some short-term testing on fiberglass, I think it's going to work perfectly fine. So the next step for us is to lift the tape and peel it back so that we can expose the bonding side of the strain gauge as well as that flex circuit. So what Ben's going to do is take this tape and kind of peel it up. Got a lot of stuff there because you've got the wire and you got to deal with that. But we're going to lift the tape at a shallow angle. And once you get past the gauge, maybe give it an extra ½ of an inch and go ahead and fold it over. And this is where if you got 3 hands or someone sitting next to you that can help you, it makes your life a lot easier. Now the goal here is to get this gauge installed. The flex circuit, we're going to let it become bonded as well onto the beam because that'll help to provide some strain relief for the cable. But absolutely the key part of this for strain transmission is that area down at the end of the flex circuit, because that's our strain gauge. And that's what we want to focus on, making sure we get good pressure on it during the entire cure cycle. So with MBond 200, it comes with a catalyst. He takes the brush cap, touches it on the inside of the bottle about 8 to 10 times, and then we're just going to wet the bonding side of the strain gauge, and we can wet the flex circuit as well. And as soon as you can see it blush with this material, that's enough. If you put it on and you can tell it's blue, you probably put it on a little too heavy. We recommend a 1 minute time to wait, and what you're waiting for is the isopropyl alcohol that's in the catalyst to evaporate. So we sit and we wait. Now, while we're waiting, one of the things I like to do is use a gauze pad as a squeegee. So take a gauze pad, I like to take it, fold it in half, and then fold it in half again, and we'll use that to help push this gauge down once we apply the adhesive. But we got to wait our full 60 seconds, and we still have a little bit of time. If you were testing other materials than fiberglass, some composites or maybe plastics, and you were concerned about the reactivity between this adhesive and the plastic, you might consider using a 2-part epoxy. We call it MBond AE10. That works great for strain gauge installations on composites and plastic as well. And one of the great things about AE10 is that it's 100% solids epoxy. So you don't have to worry about any solvents that are any adhesive that could react with that plastic or composite. So if that's a concern for you, think about using the AE10 to bond the strain gauge as opposed to the MBond 200. All right, so we've waited our 1 minute. He's going to open up the bottle, drop a few drops out that maybe collect in the nozzle. And now really we need 1 or 2 drops of adhesive right at the junction of the tape to the G10 beam. He'll take that, now he's going to pull things over and keep it on pulling over, and let's wipe it down into place. Yep, all the way out, and then get your thumb on the gauge and also put some pressure with your hand on the flex circuit. And now we're going to wait another minute. That's the great thing about using MBond 200 is that once you apply it and once you give it 1 minute of pressure, that's all the curing really that's needed. Now we normally recommend that after the 1 minute of pressure, you let it sit for another 2 minutes, and then you're ready to remove the tape. The key point to recognize, though, is after that 2 minutes, the installation, other than the environmental coating, is basically done. So you're basically ready to start testing. You could brush on some environmental coating, give that a few minutes to sit, and then you're ready to start running your test. But this beam and this adhesive and this gauge, they're ready to start reading strain as soon as you finish that 2 minute period of time to let it sit. You know, my watch, I think you're just about at 1 minute. So he's going to release his fingers, make sure that they're not stuck down, and now's a good time for an optical inspection. What I like to do is take a look at it. Of course, we need to remove the tape. We're going to let it sit for 2 minutes and then take the tape off. In this case, what you're trying to do is, as you can see it, you know, you're looking to see that you got it in the right location. You're trying to see that it's intimately down on the structure, that you don't see parts of it, that maybe a corner of the gauge or something that's lifted. And of course, we'll be able to tell that as we start to take the tape off. But one of the great things about pre-cabled strain gauges is that, you know, it takes a significant amount of time to prep and get these wires ready. And then you solder them in place, and here, all that's already done for you. So all you have to do is focus on installing the gauge. Like in this case, let it sit a couple of minutes, then we take the tape off, put on some environmental coating, and then we're off to the races. Now, the other thing about using these 3-element rosettes is that the alignment of the strain gauge is really not critical, because your reference axis when you're using a 3-element rosette turns out to be the axis of what we refer to as grid number 1. And grid number 1 is the grid that's all the way over here to the left-hand side, and that is our reference axis. So we could choose to orient the strain gauge in any direction that we want to, and that reference axis will move. But when we start our calculations and we're calculating principal strains and direction, we can still calculate that maximum principal strain no matter which angle we turn it. It's just the angle calculation will vary as we do that, assuming the load stayed in the same direction. So a very powerful tool using these little small 3-element rosettes. As you can see, they're relatively easy to put on. It takes just a few minutes of surface preparation, and then we glue it down, and we should be ready to take the tape off at this point. Yep, we've got the tape off. At least mostly off. And really just a couple of steps left. We need to add some strain relief for the cable, help to hold that down onto the beam. And then we will add some environmental coating. So I'm going to pull that apart just a little bit, maybe. If that makes it easier, I'll let you do it. Yep, that simple, that easy. Uses the handle end of a cotton tip applicator and a pair of tweezers. Puts a little, looks like a little inchworm in the wire. And then I'll take a piece of paper drafting tape, put that over the end, just kind of wrap it around. And it's really that simple and that easy. So now we've got the gauge installed. Really the last step in about any strain gauge installation is to put on the environmental coating. So in this case, we've got the M-Coat-A, which is a single component polyurethane, no mixing required. It comes in a brush cap applicator, or comes with a brush cap applicator, just like this small bottle. And what we're going to do is we're going to open that up, and we want to cover any exposed electrical connections. So we're going to cover over top of the solder connections on the flex circuit, cover over the flex circuit, and also cover over top of the strain gauge. This will form a very thin layer over top of the gauge that's kind of similar to coatings that manufacturers put on printed circuit boards. Pretty simple to put on, pretty easy to use, and it takes about 20 minutes for this to air dry where you can touch it. Full cure is about 24 hours. So at this point, we're basically done with the installation. We let it finish curing, and then we can take it and go test it. All right, so this is an example of an installation using one of the new C4A series strain gauges. As you've seen, it's relatively easy to handle, pretty robust because now we have this new flex circuit. In part of the flex circuit, you'll see a strain relief, not quite a loop, but a serpentine that you'll see in about the middle. That allows for some flexibility. We've got this entire strip bonded. We've got the rosette here, the flex circuit, and then of course the ribbon cable. So why would you use this? You use this type of strain gauge when you've got applications where you're not sure of principal strains and direction. That's when you want to use a rosette or a 3-element rosette, and this is a rectangular style rosette. And what that means is that the 3 grids are at 45-degree angles to each other. So grid 1 is at a 45 versus 2, 2's at a 45 versus 3. It's a very common geometry for rosette type strain gauges. So use these when you're not sure about direction. Also, you typically like to use these, or we like to use these when we've got areas that have very localized stress concentrations or very tight spots. Common applications would be welded junctions, parts that have holes drilled in it, printed circuit board assemblies. These types of strain gauges are really targeted for those types of applications. Now, if you'd like to find out more about this C4A series strain gauge or strain gauges in general, please feel free to reach out to us at www.micro-measurements.com or call us. You can call the Applications Engineering Department at 919-365-3800 and just follow the prompts until you get to Applications Engineering. Thank you for taking the time to go through this installation with us. And thank you, Ben.